Danke, Georg. Ich muss euch jetzt unterbrechen, aber wir haben am Ende der Session noch auch Zeit für weitere Diskussionen im Fall. Danke nochmals für diese sehr interessante Präsentation. So the next one, not only increasing temperatures can change streams' habitat conditions, we will see now also humans can contribute strongly to variations. Magdalena? Assessing variations on stream benthic macroinvertebrates following changes in the catchment of the Long Term Ecological Research site in Matsch Valley. Please, the floor is yours.
Thank you. Hello everyone, also from my side. As already heard, I'm currently conducting my master thesis at European Research. Oh, sorry, I can put my mask down. And yeah, looking at the variation of stream benthic macroinvertebrates following changes in the catchment of the Long Term Ecological Research site at the Saldur stream in Matsch Valley. So, as an introduction, we already heard alpine streams are very vulnerable environments, especially looking at climate change due to global warming resulting in loss of glaciers and also snowpacks. And macroinvertebrates have been established as a very good indicator for these environments to monitor them. To go back in time a little bit and to understand what we are studying, in 2011, Europe started the long-term monitoring in Matsch Valley, and in 2014 it was integrated in the global ILTER network, and in 2015 a runoff river power plant was built at the Saldur stream in Matsch Valley, and also a study was conducted to find some reference data already before the runoff river power plant was built. You can also see the runoff river power plant here in the picture, where the weir is visible. And now we are currently in the sampling season of 2020, and we try to compare the sampling season of 2020 with the sampling season of 2015. This leads me to my research questions. Since these benthic aquatic and macroinvertebrates are widely used as bioindicators for water quality, we want to see if there is a significant difference in the aquatic macroinvertebrate assemblages driven by the impact of this small runoff river hydropower plant, since it is used as a green energy tool. And if there is an impact, can we identify any trends on the species replacement at turnover or richness differences, or even vanishment of species? So the Matsch Valley is located in the Finchgau, as probably every one of you knows, and its the reach is 101 square kilometers, spanning from 920 meters above sea level to 3,740 meters above sea level. And here you can see our sampling sites distributed alongside the Saldur stream. The Saldur stream is a glacier-fed stream by the Matsch Glacier, which is also currently shrinking in size and losing size. And we have our reference points at sampling site number 1 without any effects of tributaries or a power plant. And then at station 2A to 2C, they are distributed very close to each other, right next to the weir. So station 2A is on the weir of the runoff river plant, 2B is right underneath the weir, and 2C is at the outlet of the small hydropower plant. The station 2D is located right next to a tributary of the Saldur stream, and station 3 marks the closing point of our catchment at the Saldur stream. So for the methods, we used the exact same sampling design as in 2015. So a sampling collection on a monthly basis from May 2015, respectively 2020, to September. We measured abiotic variables, for example, water temperature, water conductivity, suspended solids, and the Fankuch index, which tells us about the riverbed and the stability. And of course, also macroinvertebrates. We sampled them with a server sampler. In each site, we did 3 replicates. And after the collection, we do the sorting in the lab, the identification, and then the establishment of a taxa list. So to get to the preliminary results, or the results of 2015, we saw in 2015 there were 6,631 individuals collected, distributed among 27 taxa. Most prominently, Protonemura, Chironomidae, and Betis. As we already heard, they are very prominent species in glacier-fed rivers. And in 2015, we saw pretty low densities, and now in 2020, for only May to July, I have to add, because in 2015 we see the whole sampling period, and in 2020 we only see the results for May, June, and July. We have higher densities in 2020. For the ecological indices we could already analyze, we saw also a very common trend with higher values at station 2D and 3, which is due to their distance to the glacier, because with increasing distance to the glacier, the influence of the glacier itself decreases. We have probably less suspended solids, and therefore we have higher densities and higher diversities in those sites 2D and 3. Yeah, and also we already calculated the percentage of EPT, Ephemeroptera, Plecoptera, and Trichoptera. Again, here we have the whole sampling season for 2015 on the left side and for 2020 on the right side. And we see a very similar trend, let's say. But for the further analysis, we still have to add for 2020 the data of August and September, so there is still some analysis to do. This is just a preliminary result. And to explain this data, we have to look again at the glacier melting dynamics. And here it is shown the seasonal hydrograph in the graph A, where we can see the peaks in the summer period, with the snow melting occurring in June and July, and the glacier melting mainly in August, with very high peaks of discharge in August as well. Then the second graph shows the base flow of the Saldur stream in March of 2014. And then in C, as a contrast to graph B, we see the flow during the glacier melting season in the Saldur stream over the day. So we have a daily comparison. And the peaks again in graph C show very well that in the afternoon, the late afternoon and the evening, the glacier influence is highest with peaks in discharge. Also here again, we have the annual comparison of the glacier melt from 2009 to 2016. With very high peaks in August, since the glacier melt is occurring in the summer periods. And for 2015, we already also see the densities of the macroinvertebrates. And we see they are pretty low in this year. And for now, we can only suggest some ideas why this is the case. And we will see with the next data if we can make some nicer suggestions. Yeah, and also here in the pictures, you can see on the left side a picture of the Saldur stream at the runoff river plant in the morning with very clear water, and then in the late afternoon with very less visibility, higher suspended solids, and this is over the course of one day. So the glacier influence is increasing in the afternoon. For our results of the abiotic conditions, we compared very shortly May to July, and we already see some differences, but they are not very distinct, not too high. We have higher conductivities in 2020 and lower suspended solids also in 2020. For results in the land use change, we did a small GIS analysis on local scale, and for the whole catchment there was not really a change in agricultural activities, mainly to anthropogenic activities. And in the when we look at the catchment until the site 3 of our sampling site, we saw a little decrease of agricultural activities, but we still expect not really an effect on our macrobenthic assemblages. because there are, in general, not many agricultural activities in the catchment of the Saldur stream. So this leads me to the outlook of this study. Our scientific goal is still to investigate the effect of the small runoff river hydropower plant, and we have to finish the sampling season of 2020. We still have one sampling day in September and have to analyze the August and September data. And also there will be another study on evaluating species replacement and richness differences over the last 5 years, so also including the data of 2016, 17, 18, and 19, which we didn't include in the master thesis. We are just comparing really 2015 and 2020. With that, I want to thank you for your attention, and I'm happy to answer questions in German or English.
Thank you very much, Magdalena. So, are there questions for her? Now I have to look very well. Georg.
Thank you for the nice presentation. Based on the data you have, you are supposed to get some results. But I recommend not just looking at the species turnover and biodiversity or diversity of the communities, but looking at specific groups. As I presented before, there might be groups that react differently to changes.
Yes.
So this is just...
Yeah, this was already done in the study of 2015. I just had too less time to present that as well, and we will also do it for 2020. So cluster analysis and also EPT, very close look on that, and also on the different taxa groups.
Okay.
So in order to do the biodiversity analysis, do you only study the taxa information, and how do you identify the taxa? Is it just based on the visual observation, or do you use also genetic analysis? Because genetic analysis can give you a very deeper insights into the biodiversity present.
Yes, for sure. We only identify under the microscope, so to genus and family level. But genetic analysis would be very interesting, of course, but that would be way much more work. But for another study, it would be probably interesting. So it's a nice input for further studies, though.
There are other questions? Okay. If not, have I seen it well this time? Okay. If not, then thank you again, Magdalena. And now, from the importance of macroinvertebrates, we will now concentrate our attention to another important group of aquatic organisms. And which environmental factors shape the aquatic bryophytes community in selected mountain streams in the Eastern Alps? Please, Magdalena. Thank you.